When we talk about circuits, or the way wires and such are laid out so that we can get information from one place to another, we talk about two different kinds: physical circuits and logical circuits. So we're going to tease out the difference between the two right now. So let's start with physical circuits. These are the easy ones. Physical circuits, a circuit is one in which you only really have one path to get from one place to another. You may remember in the old telephone days, you'd have a telephone, a switchboard operator who would plug the wire into one and then plug the wire into the other, and you would have a physical circuit going from one place to another. There's only one path that it can take. There's never any variation in the path that that voice takes. In the case of data networking, we do something similar. What this is called right here is a bus circuit, or a bus topology sometimes. In this case, if this computer speaks on this wire, this computer hears it and this computer hears it. They both hear it because there's only one way for that to go, and it goes down the wire. If this one speaks, it goes out both ways and everybody hears it. So this is what we call a bus topology, and it is a physical circuit. There's really only one wire and one way for stuff to go. Now it can go either direction on there, but really it's only one single wire. Now let's start talking about logical circuits. So when we say logical circuit, we're talking about the actual way signals flow, regardless of how it's connected physically. So in this case, I have at the center a hub. Now we haven't really talked about what hubs do very much yet, but I'll just give you a little foretaste of it. When you talk on a hub, or when a hub receives a signal, it sends it out every other port on that hub. So thus, when this computer talks, both of these computers hear that conversation. And when this one talks, both of these computers hear that conversation. And the same thing with this one. Well, that sounds very much like a bus, doesn't it? So what we have is kind of a star formation. We call that a physical star, but the way the signals are actually traveling through it looks very much like a bus. You can imagine this as just wires all tied together right here in the middle. Suppose I took all these wires and just connected all three wires together. So that would be a logical bus, even though physically it takes a completely different shape from the bus shape. It's a star formation. There's another meaning by which we can use logical circuits, and that is when we have more than one direction that something can go. Now here I've got switches instead of hubs. We haven't talked about what switches do yet, but I'll give you the real quick lowdown on it. Unlike a hub, with a switch, the signal comes into the switch and it only goes out the other port that's required to go out. So you can see if a signal came in from this PC, it has different ways that it could go. So imagine if I have packets, one packet could go out this way across the top here, and the second packet could go out this way down here. Maybe a third packet could go this way and then back again, and then over here, and then out there. Another one could go this way. So we have different ways that these packets could go. Now as far as the end is concerned, this looks like a physical circuit, right? As far as these two know, these things are directly connected, and it appears to be traveling only along one route. Now it is possible that I could set up here a physical circuit. I could say, well, if this computer wants to talk to this computer, then the switch should always send the information here, and then that switch should always send the information here. And that way these two would never be used. That would be a physical circuit. Or I can split it up, and some of the conversation could go one way, some of the conversation could go another way, and then I have a logical circuit because the flow of information varies from the actual physical setup. So we have two really kind of distinct meanings of logical circuit here. This one and then this case back here. And we'll use both forms of this as we go along in this course.